8. Minimum adds reversals, so every node is reachable. So let's first understand this example. Try to understand the question by using this example. So for this example, we know that if we are starting from the root node 2, it's going to be connected to 1, 1 connected to 3, and 2 connected to 0. So this is a tree structure, but the graph is directed graph. So for example, we have the edges 2 to 0, and 2 to 1, and 1 to 3. And we need to return a result. So the result is going to be the node 0. So for example, the first one going to be starting from 0. And we just need to count how many reversed edges we can get if this node can be reachable to all other nodes. So this means we just need to turn this edge. So from 2 to 0 to 0 to 2, now this 0 can be reachable to 2, 1, and 3. So the answer is going to be 1. And the next, let's just check the next, it's going to be the node 1. So for node 1, we're going to start from here. So node 1 is reachable to 3, but not reachable to 2. We just need to change this edge, so it's going to be 1. So the node 1 going to be 1. And then we're going to check the node 2. So let's just check the node 2. So for node 2, it is reachable to all other nodes. It is okay, so it's going to be 0. And now let's just check the node 3. So for the node 3, we need to change this edge from 3 to 1, and this edge from 1 to 2, so the result is going to be 2. So this is our final answer. It seems this problem has some patterns. I'm not sure what kind of a method you're going to think about this problem. But basically, this is a graph problem, and it is a directed graph problem. And definitely we cannot solve it by using O(n) squared time, because let's just check, n going to be 10 to the power 5. This seems we can solve this problem by using O(n) time. So basically, it's really difficult to solve a graph problem by using the n log n time. According to the design patterns, basically it's going to be O(n) time. So if it is O(n) time and it is a graph problem, and specifically it is a tree problem, maybe we can solve it by using DP. So it's going to be a DP or trees problem. So this is a tree structure, and we're going to use DP. So the idea is that what if we can calculate the previous result before? So for example, we're going to start from the node 0. How many edges we need to change? There's only one edge we need to change. So we're going to record a final result. So the result going to be 1. So it means we only need to change one edge if we are starting from this node 0. So the result is going to be 1 currently. Now, this node 0 going to go to this node 2. But how can this node 0 goes to node 2? Because this is a directed graph. How can it go to node 2? We cannot. But we can turn this directed graph to undirected graph. So if it is undirected, so it is okay. So this means the graph from the beginning, it is directed. Now, we're going to turn this graph to undirected graph, because this is going to be easier for us to solve the problem. We just need to see this problem as a traversal problem, because if it is undirected, it means from node 0 we can go to node 2, 1, 3. For node 2 we can go to 1, 3, or 0. So for each of the nodes we can go to any other nodes if we turn it into an undirected graph. But what if we turn it to an undirected graph? How can we record if this edge is reversed or not? So we can turn this edge into a set. We can put the tuples inside a set. So now we're going to have a set. So inside the set, we're going to have all those edges. Now it seems that the problem becomes solvable. So if we turn this graph into an undirected graph, so we're going to start from the node 0, and we put all those edges inside a set, we can check if there is a reverse or not. So now let's just start it from the node 0. So 0 to 2, is it inside the set? It is not inside the set. So if it is not inside the set, it means we need to increase the edge by 1. Basically, it means we're going to reverse an edge. And now we're going to start from 2 to 1, it is inside the set, it is okay. 1 to 3, it is inside the set, it is okay. So for this node 0, the final result is going to be 1. But we cannot use this kind of method to use another O(n) time, because it's going to be O(n) squared. So this means we're going to use the DP or trace. And basically, it's a reroute to solve the problem. if we use the reroute method or the swap to root method, so from the beginning it is a 0 and the result is 1. Now we're gonna start the root as 2. So this means the root 0 gonna change to root 2. Let me use another drawing. So the root 0 gonna swap with this root 2. So what happens? So if root 0 goes to root 2, we didn't change all other relative properties of the edges. So for example, the edge from 1 to 3, it is still the same. 1 directed to 3 and 2 to 1, it's still the same. 2 directed to 1. But what changes from the beginning, it is 2 directed to 0. After we swap the node from 0 to 2, what happens? Yeah, we just need to understand what happens. If we understand it, basically we've solved the problem. Yeah. So from the while we are starting from 0, so the count is 1 because we need to reverse 1 edge from 0 to 2 from 2 to 0 to 0 to 2. We need to reverse 1 edge. Now we are in this node 2. Yeah. So if we are in this node 2, we just need to check. So from the beginning, it is this edge is going to be 0 to 2, while we are starting from the node 0. 0 to 2 is not inside of the set, so it means we're going to increase this edge. Yeah. Now our root is going to become this node 2. So now what happens is from the beginning the edge is 0 to 2, but after we change the root to 2, what happens is our edge also changes. From 0 to 2, it's going to become 2 to 0. So what happens for this 2 to 0? So 2 to 0 is inside the set. This makes the problem solvable. So if 2 to 0 is inside the set, so this means we're going to reduce this count. So from the beginning, this count is 1. Because this 2 to 0 is inside the set. If it is inside the set, we're going to minus a 1. And then we're going to check this 0 to 2. Is 0 to 2 inside the set or not? So 0 to 2 is not inside the set. So we need to plus a 0. So this is just the formula. So if we can solve this problem by using this kind of formula, basically, yeah, it's going to become really easy for us to solve the problem. Now I think we can go to the code editor to start coding. And basically, while you see that kind of a formula, it's going to be really easy to understand. So for this kind of idea, we just need to change the direction, because 2 to 0, 0 to 2, it's just a direction. While we are starting the root 0, so the direction is we're going to start from 0 to 2. Basically, we need to change the edge. But while we're starting from the root node 2, 2 to 0 is inside the set. It means we don't need to change it. Yeah, so from the beginning it is 1. Now we need to minus a 1 because we don't need to change this one. So it's going to become 0. So this is going to be the node 2. So from here, the node 2 is going to become 0. Yeah. Now let's start coding. So we're going to turn this graph into an undirected graph. So I'm going to prepare a default dict with list, and then check the edges. So let's just prepare this undirected graph, and similarly this GV gonna append U. Now basically we need two functions, a DFS with x and parent, and another function I'm gonna call it reroute. Similarly, it's gonna be the x and parent. Yeah. So basically, we're going to need those two functions to solve the problem. But before that, let's just do some preparations. So I'm going to prepare self.count. It's going to be 0. So this means starting from node 0, how many edges I need to reverse. So this is my count. Yeah. So finally, I'm going to call this DFS. So it's going to be starting from node 0, and the parent is going to be -1. Now let's just finish the basic pattern. So for y in gx, if y not equal to the parent, so we're going to call the DFS with y and x. Yeah, but from where we need to update the self.count. So basically we need to update this self.count. So we can update it from here. So basically we are starting from this node 0 and it will go to node 2. So we're gonna check it from here. So if xy tuple is inside a set, so we're gonna update the self.count. And we also need to prepare this set. So it's gonna be a set, and inside it's gonna be tuple uv. So for uv in as is. So if I call this DFS, what happens? Let's just check the self.count. What happens for the self.count? And from here, let me just give a pass and return a 0. Now let's just check this self.count after this DFS. So the output is 2. This is not what I expected. I think it's gonna be 1. So the output is 2. Let me check. Yeah, it should not inside the set. So if x, y tuple not inside of the set, yeah, because 0, 2, it is not inside of the set, so we're going to count it by 1. If it is inside the set, we don't need to count it, because we only need to count how many edges we need to reverse. Yeah, now let's just check. So currently the output is 1. It seems that everything should be okay. If the output is 1, I'm gonna start the reroute function. Let me just delete this print. And for the reroute function, basically I need to copy the same code from before, and I don't need to have this kind of a tag. And I need to call the reroute function. So for the reroute function, it's going to be 0 and -1, and I need to use this self.count from the node 0, because currently the node is 0, but for the next I'm gonna swap the root from 0 to 2. So inside I need a count, and this one gonna be the reroute yx, and here is our formula. Actually we need to update the count from here. Yeah, if we can find this formula, basically we've solved the problem. Yeah, but from here we need to update the result array. I think I didn't prepare the result array, so it's going to be 0 times n. So from here we're going to update the result array. It's going to be starting from the node x is going to be 0, and then it's going to be node 2, 1, and 3. So the result x is going to be equal to the count. So now let's just update from here, because from the beginning the root node is 0. Now the root node is going to become 2. From the beginning it is 0 to 2. Now it's going to become 2 to 0, and this is our count. So for this count, we need to minus set, as I explained earlier. So basically it means the yx, if it is inside, we need to minus this yx. So yx, if it is inside the set. Yeah, and we need to plus another one, and we need to plus this x and y. Let me use x and y tuple inside the set. Yeah, so this is the basic formula for us to solve the problem. So from the beginning, we are starting from node 0, and the count is 1. Now we're gonna check this yx. So yx is gonna be 0 to 2. So 0, 2 is inside of the set. It means we're gonna need to minus 1. So the result is gonna be 0. And we still need to check this x and y inside of the set or not. And the x, y gonna be 0 to 2. And 0 to 2 is not inside of the set. So we're gonna plus 0 and minus 1. So the final result is gonna be 0 for this node 2. Yeah. I think that's all for 8. Yeah, I think that's all for 8. Let me just run it. Yeah, so basically you need to understand why we're going to use this kind of formula. Because from the beginning, after we change the root, if we find it at 0 to 2, if it is inside the set, it means we need to reduce it by 1. but from the beginning, if x and y is not inside the set, after we go to 2, if it is inside the set, we need 2 plus 1. So for example, if we don't have this as 2 to 0, if we have an as from 0 to 2, what happens? Yeah, so from the beginning, this node 0, the result is going to be 0, because 0 can be reachable to 2, 1, and 3. Now we're going to start with this node 2. So while we are starting from this node 2, 2 to 0, so 0 to 2 is inside of the set. This is going to be 0 to 2. Yeah. So this yx, 2 to 0, is not inside the set. So it means we're going to minus a 0. And this xy, it means 0 to 2 is inside the set. It means we need to plus 1. Yeah. So it means from the node 0 goes to node 2, our final result is going to become 1. Yeah, so this means 2 to 1, 2 to 3 is okay, but 2 to 0 not okay. We need to reverse the as. Yeah, so this means the formula should be okay. Now let me just run it to have a basic check. I think I need to return the result array, not 0. Now let me just run it. Now as you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and I think the speed is okay, because basically this is a on time solution. And yeah, I think that's all for it. The difficult part maybe you need to find why we can solve this problem by using a set, and why we can turn this undirected graph to directed graph to undirected graph. Basically, if you understand that, you just need to find the final formula, because we only changed one as direction, relative direction. I mean, from the node 0, the direction is not okay, but from the node 2, the direction is okay, and this is the formula to check, and we need to update the code from here. I think that's all for it. Thank you for watching. See you next time.